Hey guys, so I'm on my way out to go do some stuff. I have a plumbing thing I got to do and a roof repair, but this is the insulation I was talking about for the inside of the Creatbot. This is the bubble insulation you put around ductwork to retain the heat. So it's perfect for retaining heat in here. And I've already done the bottom and parts of the sides. The back, where the heat comes in, is where these blue grids are, and I'm going to try to add my heater there too, but I'm not doing the back wall yet because, first of all, this goes into the filament chamber, so I'm going to have to maintain these boxes, or these octagons, so I'm going to cut or hexagons actually, so I'm going to have to cut those out of the insulation so that it still transfers into the filament chamber, and then I'm going to also insulate the filament chamber, but then I'm going to bring the Z-axis down, and I'm going to do these top sections as well, and I'm going to do the top ceiling around the door. So it's going to be completely insulated inside everywhere it can be, other than where heat is coming in, or it's going into the filament chamber, which is also insulated, or it's where the panels are, which I'm going to double those panels up now that I am going to high temperature condition it with the extra heat and the insulation. So I have the extra heaters coming in today. I have grid heaters, ceramic heaters, fans. So I'm going to make this very high temperature inside. I'm going to condition it to be able to be capable of very high temperatures, higher than it's rated for, because the firmware actually gets it to 500 at the nozzle, 200 at the bed, and 150 in the chamber. If I can reach those temperatures, this thing will be capable of a lot more. So I'm going to get it there, and I'm definitely going to, but I don't know how quickly I have to look into the hardware as far as the electronics, what electronics to upgrade it with, because I'm going to make it local area network and Wi-Fi capable and a little bit more friendly user experience with the interface. So it printed yesterday. Oh shit, it melted. See, this bird cage came out perfectly. Damn it. I just put a little bit of heat to it, but it's so small that it literally melted it in half. But this came out perfect. Like, even the little bird inside, look at the little bird. And this is like thumbnail size. And it was perfect. I wish I got to show it to you perfect, because even that tiny little bit of heat just melted it, because they're so tiny. But the fact that they're so small and it came out perfect is really impressive to me. So I'm going to do an overhang test. I'm going to put ABS in it this time. I want to do something a little bit higher temperature that actually has, the filter installed and all that. So I'm going to do that while I'm out doing these repairs. I'll let it print while I'm gone. I'm probably not going to insulate any further until I get back, because ABS doesn't need crazy high heat. But I am going to finish the insulation this afternoon. I'll record another segment where you guys can see the overhang test, as well as you can see that the overhang test, as well as the rest of the insulation, and then I'll start printing the two side panes. This pane is probably going to be too large to print, but I'll put some clear PC in the QIDI printer and start doing these side panes. So I'll probably have at least one of the side panes printed by the time I get back, and then I can double pane that, and then I'll just drill and tap the holes, and then I can have that going, as well as the excuse me, I'm having a brain fart, as well as the rest of the insulation. So, and I'm gonna just put one full piece above those blue panels with those hexagons cut out, and then these little slits right here that are for ventilation, you can't see them from there, on the side of the printer here, I'm just going to cut those out of the insulation on the inside. So I'll probably just put it up and then cut those out with an X-Acto or one of my little surgical knives. I have scalpels, number 10 scalpels from the dentist office, so I'll cut that out with that, because that'll cut it nice and clean. And this thing will be really well insulated, and then when I add the more heat to it, it'll be really hot in there. So I have two 24 and two 12 volt ceramic and two 24 and two 12 volt grid heaters with fans coming in. So I'm planning on doing one of each in here I'm going to have the ceramic heater right behind the grid heater with the fan, so it's going to get heated twice on its way into the chamber. And then when it gets into the chamber, it should be plenty hot coming out of both of those heaters. So that'll probably more than double. I don't think they even have that much heating in here already. I don't know for sure because I haven't had a chance to see it. But I'm going to be opening up those parts today when I start doing this stuff after work. I have to go do my real job for a while, and then I'll come back and do that. But in the meantime, I'm going to have it printing an overhang test. So yesterday I did bamboo PLA Tough. Today I think I'm going to use ABS in here, or maybe I'll do a regular PLA Plus. All right, so yeah, this is where the filter goes. All right, I hadn't put this in yesterday, so since I'm probably going to be using ABS or something, but there's actually room for a heater right there. So actually I can open these panels from inside, and there's their heaters. Let's see what they got in here. Oh, they got them screwed right into the metal bracket. So when I take this out, they should be right attached to it. So then I could see what voltage they are, and if I could tap into those wires that go to these heaters. I have these little small things that double tap. They tap the hot and the negative. So they tap the two smaller gauge wires, and then they go into two smaller gauge wires with one tap. So I'll wire tap those, and I'll go to the other heaters. And this is on a high amp breaker in the panel, so I have tons of power here. So even if I needed a 30 amp 120, I could put a 2-pole 30 that's for a 120 and give it all the power it needs. So we'll see. I'll do the calculation by the wattage of each one and see how much it's going to need as far as amperage. But voltage is going to still be a 110. Okay, so the other panel is loose, but those heaters are keeping it from wanting to come all the way out, and plus I just put insulation in the way. So I think I'm going to have to take the top one off at least. These screws that are holding the top one in, I don't really want to do that, but... Okay, so it looks like they actually do have a ceramic. And then there's the thermostats. Okay, so I guess I'll just essentially be doubling the heat, but mine is smaller, so that's a good thing because the fan is right there with where this goes. So that's I'm going to use the activated carbon on the inside, and then I'll put one of the two heaters. I'll put the ceramic because it's taller and thinner on this side, and I'll wrap those wires so it doesn't heat up those wires too much that are in the corner. I'll put some insulation around those, or over top of those, and then I'll put the heater, and then I'll put another heater over here, and I'll put a fan on the stepper motor to keep that cool. Because that's going to be behind the heat anyways. The heat's going to be aiming into the chamber and coming in this way, so it should actually keep it cool anyway. But anyways, that's what I'm going to be doing, and I'll show you the overhang test later and do another video where you can see that and you can see the rest of what I do here. All right, thanks guys. Hey guys, what's going on? It's Chris. So I've gotten some of the parts, most of the, well, probably more than half of the parts that I'm going to be using to modify my new Creatbot. So I'm going to turn you over here. I'll show you what I mean. Right now I'm printing on the bamboo at its full capacity, 300 degrees Celsius on the nozzle and 120 on the bed, and I've got it up to 50 in the chamber. I'm printing the bracket that's going to mount the Bondtech. I got a right side and a left side tensioning screw for the Bondtech extruders, so I'm going to be using both of those in here. And then this is the 3.5-inch touchscreen and the Raspberry Pi and the heat sinks and all that kind of stuff. And the power supply I'm going to be using for these heaters, and this is, the rest of the heaters came in. So this box is completely full of heaters, ceramic and grid heaters with fans. And this is a dial control for the, that's a dial control for this. And this has a dial on it also and the voltage on top. And then I didn't have a regular desktop power supply. I had a 120 to 220 that you could turn up and down, and I used that, but I got a regular power supply, desktop power supply. So, and I'm going to use it right now. I just tinned the tip of these wires. This is going to be the power source for that. But before I crimp the fittings on, it's ground and then blue and brown, so I'm not sure which is neutral, which is positive. So I'm going to test and figure that out right now. I could use a multimeter, but I just got this, so I figured I may as well give it a shot. All right, so, and I used my own leads. I have leads that you can thread the end off and make it, you know, make it something else. What's going on? Really, dude? I just had it on. There we go. Oh, this plug is loose in the back. That's gonna do it. All right. Okay, so let's take that off so I can see. All right. So let's see. Let's put one to ground. This is the ground, and then these are the positive and negative. So let's try it here. And well, it's not going to actually draw any power, so I need to plug this in first. And then actually, you know what? I do need to use a multimeter. So I'll turn on my soldering microscope. I have a multimeter on this. I also have my little handheld oscilloscope multimeter right there, but I'm going to use this for now. This has got great probes on it. These are really tiny at the end. I mean, I have adapters that I could have put something else on, but you can't really see anything on the screen because you don't need to right now, but where's my multimeter? Oh, wait. No, I don't need to record. Where's the freaking remote for this thing? There's a remote control for it. So I've actually communicated with Creatbot, and despite all the stuff that I've read about their support being like non-existent, it's actually not non-existent. They did respond. They were willing to help me with the modifications, which I was kind of surprised about and pleasantly. The only thing I'm having a not so good experience with is their build plate on the site where I ordered it said it was a glass build plate, a ceramic glass build plate. It's not. It's aluminum, and it's not removable. And then the stuff you get for it, like they refunded me for the carbon fiber and I didn't have to send it back. That's nice. Thank you. But it's $150 and I paid $180 for the PEI sheet, which works really well. And I put it in and it's on there. That's what's on the build surface right now. But that's a wear item. That's going to keep wearing out. That's $180 every time. I'm going to have to keep one or two of them on standby. I mean, that it's going to add up way faster than glass, and I don't think it works as good for as glass on certain high temperature materials. But I mean, I'm using the Wham Bam PEI plate on the bamboo right now, and that's what's printing this high temperature material. So, and it's staying at 300C now. Every time it wants to look at a layer and adjust, then that's when it changes the temperature back down. So I need to just plug this in and see what's hot and what's neutral, which is really easy. I literally just got that 5 minutes ago. My delivery, well, not 5 minutes ago, 15 minutes ago. My delivery came, so I'm gonna start setting this stuff up. Okay, the brown wire's hot. Blue's neutral. All right, so I'm going to crimp some fork fittings on here, fork connectors. All right, I'll bring you over to my other table here, where I kept the laptop on the bench because I need to keep an eye on that and make sure it's not changing the temperature. Because I had that stuff in there and it literally would not extrude at, 270 or 260. This is PPS. It's some extreme nylon, extreme high temperature nylon, and it works. It is really, I mean, it's resistant to up to 280C. I just saw it, or what, 260, whatever it was, because it wouldn't melt. It literally would not melt. And So these are kind of essential if you're going to do this stuff. You got to have a proper pair of crimpers with all the different heads for the different types of fittings, because when you do like pin outs on the boards, you're going to need all the different pin connections, and you know, you want to crimp them right. I mean, I don't really need to be doing heat shrink watertight connections on this, but I'm doing them anyways because I just like to be thorough. If you buy these online, they're not that expensive. They're really not. I mean, I get whole boxes of assortments for 20 bucks, or, you know, like you can get a whole massive amount of one fitting that you use the most for even less. I'll bring my heat gun over here because I'm going to need to heat shrink a bunch of stuff. So this whole section over here is all stuff that wasn't here. This is all the new add-on to my smaller workshop. Which, it's my smaller workshop, but it's neater. You know, like it has my 3D printing and air guns, but none of the big metal machines, which that workshop gets to be a mess. And this workshop I can keep relatively clean, so it's more comfortable to work in. I mean, when I need to do stuff like that, I need to do it in there. When I need to do the CNC machine or the lathe or plasma cutting and all this stuff that makes a mess, you know, I mean, don't get me wrong, I'm not afraid of getting dirty, obviously, but I don't like to hang out in dirty when I don't have to. But I do have a lot of fun in there, so I'm not complaining overall, that's for sure. All right, let's see. Let's get this in there. Of course, these forks are just a hair too big, so let's grab a pair of pliers and pinch them down a little bit. Where's my linesman? I just had my linesman, I just used it. Here we go. Most of the time I prefer Klein for electrical tools, but honestly, Milwaukee's been coming out with some really good electrical stuff recently. Most recently, they've been coming out with a lot of new stuff, and like all this stuff up on the wall next to me, that's mostly new. But the electrical stuff, they didn't really make high-grade electrical stuff, and now they are. And the small snips are great for 3D printing. I'm sure everybody uses small cutoffs. These are very small and very precise, and I have literally 3 pairs of them already because I have one in each location where I would use them. But these are 11 bucks, and they're incredibly sharp and incredibly accurately clean. Like they cut right in directly in the right spot, and nice clean cuts. All right, so the extruder, I already know it works with my stepper motor. I don't know, I may upgrade the steppers also. Brown was hot, so this is gonna be, no, my blue was hot, right? We'll find out. Let's find out right now. I forgot which one it was. I wish you guys could talk to me through the video. That would be helpful. You could say, hey, you just tested and it was the blue or it was the brown. Yeah, brown. All right, so blue goes to neutral and brown goes to positive. And then this is going to be my power source for, I've got some heavier gauge wire, the spools on top of it, that I'm going to use for this. And these are going to go to each of the printers for their heating elements, because it has 3 outputs. Oh, hello. Yeah, let's not touch the metal with it. I shouldn't have had it plugged in yet. Okay. It's probably a better idea to do it that way. I forgot that it was plugged in, or I would have been more careful. I usually can install breakers with the power on and all that, but I'm careful because I know that they're on. I didn't remember this was on. So I got the Raspberry Pi, the touch screen for it, the ribbon cable, the extended ribbon cable for the camera, and the camera came yesterday. The other extruder's coming tomorrow, and then I actually sent pictures of the main boards and subboards that I was planning on getting to Creatbot, and they're going to take a look at them and let me know. And he said he would help me with whatever I needed, which, you know, he said if you have any problems, reach out to us. And I thought it was very nice because they know I'm modifying the printer, which, you know, I know they'll still support their parts, but there's not going to be a whole lot of them left in the printer anyways. If the stepper motors, maybe, and they're going to actually do something custom for the glass build plate to be removable, not only to be the glass, but also to be a removable glass build plate, so that I can change it. And they're going to make something for me, which when they said that, I was like, wow, I really appreciate that. But I think it'll benefit you guys too, because this is still a really good industrial printer. I mean, it puts the Intamps to shame. It really does. And as far as the hardware, like the build of it, the linear rails, the linear rods, the lead screws, they're all very high. Oh, I don't actually even need this yet. I have this piece. They're all very high quality. And if they update the electronics and the build plate, this could be a printer that's much more expensive than I paid, because I wouldn't have to be doing all this. But I still would rather do this than the Intamps for sure. I don't even know how that Intamps people actually get successful prints off of it. I really don't understand how they do. So I usually tin the end of these, but these are pretty thick. I think I'll be good with these. All right, I'm going to use the blue 4 connections on these. And then I'm going to put some kind of either plate connectors or bullet connectors to let this be swapped out from one printer to another if I choose to do that. That was good. It didn't crimp that enough at all. You know what? I should be using that set. Let's take these out. It's nice. These are quick change. You can just swap out the one set of crimps for another. Where was I? I was using this to this. This next one will be better for the round ones. Okay, now we're good. Oh, that one's not. That one didn't go back in, that's why. Well, let's see if I can. I'm going to just open that back up with a pen, and then I'll put this, straighten out this wire. All right, but I'll continue to make videos later on in this, like throughout this process, so you guys can see exactly what I do on this build, because I'm pretty much rebuilding the Creatbot F430 into a modern industrial printer, not an old school 10-year-old with 10-year-old everything computer. I mean 3D printer. It's going to have all the modern computers. It's going to have all the modern stepper motors. Everything that you would find in a $20,000 printer is going to be in this printer. And I did not pay $20,000, and I won't be anywhere remotely close to that, even with all the stuff I have to buy. I mean, it's probably going to be $5,000 to $6,000 with everything I'm going to do to it, and a good amount of my time, but also I'll be able to get this thing up to what the firmware allows it to go to. Like that's 200 bed, 150 chamber, and 500 hot end. I have no doubt I'll be getting higher than the Intampsys and higher than any other printer under $15,000 to $20,000 with the modifications I'm going to make for 5. So hopefully 5 to 6. Well, this one isn't going to work. All right, let's see if you fit. We'll use a yellow one for you. Okay, that one's definitely nice and tight now. All right, so this is going to be power out number 1 and 2 and 3. So there's 1 positive and 1 negative on each side. So 1 here and 1 here. And this is going to have to come up a little higher because I didn't have any more forks. This is a hook connection. I could just use small ring terminals too. I may do that for the rest. You just got to take the screw out and do what I just did right now. And you just put a small ring terminal in there. And that's actually the best way because it won't come out even if it gets a little loose. Alright, I'll just heat shrink those right there. Alright, that's positive and 1 negative. And then I'm going to put a regular grid heater fan together, and I put the 2 negatives and the 3 positives together for it. And then I'm going to also add to that 1 ceramic heater, which this is the higher power ceramic heater. This is the wattage on this is... what are the 2 sizes I got on that? The grid heater is a 16 amp. It's a 24 volt 16 amp. And this is a 12 or 24 100 watt. So I got 100 watts and then I got some 300 watts. 100 watt, I have 3 of each. So yeah, 100 watts and 300 watts. Okay, so then I'll just use I'm going to use a connection that I can connect and disconnect. So I'm going to put all 3, or all, however many of these connections. I already soldered these together. So what I'm going to do is I'm going to solder these 2 into those. And then this is going to all get connected into 1 removable connection, which will have to be the yellow ones, because this will be big by the time I'm done. So I'm going to use yellow plate connectors. So this will not have the power going in. This will be the male. And then where the power is coming out of, you want it to be the female because it's completely covered. So these will go on there. So I'm going to turn you over to my soldering table real quick. Yeah, you guys can pretty much see what I'm doing. Well, this BL touch I gotta fix. And all right, let's see. So I had to test polarity on this, unless there's a way to tell, or maybe the polarity doesn't matter. It's all in Chinese. And these things were very cheap though. So you know what, let's just give it power and see how it works, which way it works. All right, so voltage, let's go, that's 90 volt, no, 0.90, I guess that is 90 volts. Oh, well, it's not giving anything power yet, so that's probably why that is. Let's put these probes back on the microscope. All right. So this is my negative, and so I'm actually going to need this. No, this doesn't have a ground. Let's put 1 there and 1 here. All right, there we go. Now this is 0.78, 59 watts. We need more wattage. That's got to be up to 100 watts. Oh yeah, that's turning it up. All right, so we need it right at 12 and change volts. We need 100 watts. So let's turn these up. And maybe that's all it wants. Well, it's 1.5 amps. There we go. Now we got 5, 6, 7 almost amps. But we're also at 31 volts. Oh, that's why I don't need to be in CV. How do I change that? I gotta read the manual on this on how to change the settings. I mean, power's power, but I can smell it heating up already. So I think the polarity is irrelevant. Yeah, no, the polarity doesn't matter. You know, just for shits and giggles, that gets very hot. Wow. I'm gonna go like this and see what happens. I don't think the polarity is gonna matter. No sparks, no explosions. And oh, here, you guys can see that's the power supply that I got, the desktop power supply. This is just for doing stuff like this, for testing stuff at the bench. Let's turn that down to 24. Yes, close enough. All right, I don't need it anymore right now. So it doesn't matter which one I solder them to. So I'm just going to solder these to these. And these are going to be right about in the same location. I'm probably just going to put, this is where the heat's coming out, and it's coming out through the fan. And this is going to be right behind it in some way, shape, form, or fashion. I don't know exactly how yet. But this is going to go right behind it to give additional heat to be coming out the fan. Or I may have to do them separately just because of the sheer way that this ceramic heater is so much smaller, and then put a small fan on top of it. So if that's the case, then I'll have to resolder some of this stuff. You know what, let me just tin these real quick. Turn the soldering iron on. This heats up very quickly though. This is a good soldering station. This has the gun that actually removes solder. So with the suction, it's actually really cool. So this will suck up the solder right into it, into this chamber in here. And this gets as hot as the soldering iron, and it will just suck the solder right up when you want to get rid of the old solder. It's so much easier than like one of these. I have one, I don't know where it is, but the little thing that you push the button and then you have to like let it suck it up when you release it for 1 second, and if you don't get it, you got to do it over and over. That's obviously, rather than having to do that, you just literally hold the button as long as you need, and it sucks it all up. It's obviously much easier. All right, so let's put that one here. I prefer to use solder anytime I can. It's just a much more effective way of making electrical connections, as long as they're not going to be in crazy high temperature, because solder's melting point is like, I want to say it's like 600 and so, almost between 600 and 700 Fahrenheit. So, you know, that's the chamber is not going to be that hot, that's for sure. I don't even think it'll be hot enough to soften solder. I mean, the hot end and the bed plate will, but the chamber I don't think is going to get up to temperatures that'll soften or melt solder. All right, it's kind of sloppy. I need to get them a little tighter. See, as much as aesthetics don't bother me on my guns, on my printers, they bother me on my work. Like when I do something that isn't aesthetically pleasing, that's a job, I can't accept that. I have to just redo it, or not let it happen in the first place after doing it all these years and realizing how much it bothers me when I don't get it really right. All right, let's connect these. These are going to the male connections because these are the ones that are receiving the power. So the ones giving the power, you want to have the female so they're not wide open. All right, I'm just gonna pinch these down with my linesman so they fit in there nice. Well, the solder's still a little bit soft. All right. And like I said, these are getting male connections because the power will be coming from the other side. So those need to have the female connections. And I generally always crimp it one size smaller than it is so that it's nice and tight. Oh, well, that's not nice and tight. Oh, the solder went right down when I crimped it. I'm going to crimp that on the red one. Alright, that ought to do it. Yep, that's tight now. Alright, this male connector is going to go on that side. And it's kind of tight getting in there, but that ain't going to be coming out. Alright. So both of these two are going to go in the Creatbot. And then I'm going to do 2 more that are going to go in the QIDI printer, which both of these two already have heat, but the rest I have 24 volt transformers from HVAC units over by my bamboo printers that I used for the lighting. And why is this not showing this device? It is active. Why are you saying it's offline? Seriously? There we go. Okay, it's still at 300. Perfect. Okay. Now I just need to splice these and put the other side of the connectors on here. Matter of fact, the yellow forks are going to be, the yellow plates are going to be big for that, so I'm going to use blue on this side. The plates themselves are the same size, it's just the wire connection opening. Yeah, there we go, here's my splicer. Oop. So it won't be till Monday that I get the other extruder, so I'll probably wait to install those until Monday. Or I may just install one and only use that side for now. I haven't decided yet. We'll see how far I get along with this and how long it takes. And then this one. And then we're going to heat shrink all these. Okay, these are tight. Alright, now let's connect them and heat shrink them. Alright, negative to negative and positive to positive. And let's turn on the heat gun, make these connections nice and shrunken and sealed. But I can pull these apart, so when I put it through the printer, which I'm not sure where that's going to end up being exactly, I haven't decided 100%. I have a good idea where I'm going to put it, but until I'm going to be taking that printer apart, obviously, because I have so many additional parts coming in. For now, I'm going to do the Klipper update and do the Raspberry Pi externally. But when I get the new main board and stepper drivers and all that, I'm going to be opening up the whole machine. So on the bottom, it has all the electronics underneath there, and then underneath the filament chambers. So I'm going to be opening up all that stuff and getting all that squared away and probably rewired completely, because I mean, at least I'll be able to get access to the pinout and all the stuff that I'll need for that, because Creatbot has been very kind about that, which I very much appreciate. So let's go ahead and turn this on and try it. All right. Okay, now we're going to go up to 12 volts. I'm sorry, 24 volts. 24.2. It's not turning on, is it? Oh, that connection broke. Okay, that's why. Let's turn that back off. There's no power switch though, huh? That would be nice if there was. I'm gonna have to add one. Oh, you know what I'm gonna do? I'll put this right into a Wise plug, and then I can just have Google turn it on and off. That really sucks. This thing snapped. I'm gonna need a little bit of heat to get it off. Well, that is the one that I had to crimp like 3 times. The glue in this stuff, when you shrink it, it really sticks. That's another part of why I like using it, because it really sticks when you heat shrink it. That glue is pretty good. That's on the inside, the heat activated glue. This is a male, I mean. Oh no, I'm sorry, this thing, yeah, is that right? Yeah, it is a male. Yeah, let's crimp that down so it fits in there. This is going to be a little hard to get with the linesmans now. And linesmans are give you a lot of leverage. But let's just be more safe than sorry, because I don't want to have to do this a 3rd time. A little frustrating the first time. Second time you screw it up, it pisses you right off. Now you should be good. Now let's take the plate that broke off out. And then I'm gonna program this Raspberry Pi and start to hook that stuff up, the camera, find a location for that. And this stuff, the camera can stay even when I get the new stuff. All right, plug this back in. There we go. It's on 22. Let's put on 24 volts. Oh, maybe it's only drawing 20 volts. Okay, so yeah, the ceramic heater is most definitely on. This is on. Fan's on. The heat's on both of them. Yeah, and then this with this behind it should produce a significant amount of heat. Oh, I'm sorry, it's actually blowing it out this way. I'm wondering why it's cold. It's sucking air in. Oh, that's perfect actually, because then it's going to suck it in from this one as well. That's even better. Oh wow, that's very hot. Jesus. But that's way hotter than any of the ones inside the printers now. That is way hotter. You know what? Let me get my temperature gun. I'll show you. Actually, I'll get my thermal camera and show you. Alright, you're an asshole. Let's see. Let's get the FLIR camera. I'll grab a temperature gun too, just for the hell of it. Where did I put my temperature guns? There we go. Alright, so the temperature on those right now is at 330 something degrees. 257. It's getting multiple readings, but let's look at it through the FLIR. Plus, I'm not letting it get a lot of air through the back right now. There we go. Now it's getting a lot of air. It's probably the ceramic one is at the 300 and change. That one gets really, really hot. You just got to give this a minute to boot up, and once it does, you'll see the temperatures right through it. Sorry about the wait, guys. I'm waiting myself. This is my Glock 17 for all you guys that watch the air guns. This is my regular Glock. Obviously, it's unloaded. So you can see the temperature difference, the color change for the temperature. But that'll tell you what temperature that is. And this is measuring in Celsius. So we've got 160 Celsius. It's actually saying over 160 Celsius. So that's ceramic heater is over 160 Celsius. Yeah, I'll take a picture so I can show it to you guys closer. All right, and then let's check on this. Wow, this is coming out over 160 also. Yeah, these are going to work great. And I placed them strategically inside the printer. These are going to work really well. I just wish there was a on-off switch. I'm going to install one. I'm probably going to install a small switch right on it, as well as the Y switch, because I like when I can just say, hey Google, turn off A, B, C, or D, and it just turns off. I really like my alarm system has the smart wave, or I'm sorry, Z wave. Okay, let's go to album, and then I'll show you these. So that's the actual, it's blurry because I wasn't focusing because I'm looking at it in thermal, but this is the thermal image, and it's over 160 Celsius. If you can see that, over 160 Celsius. 19.7 C is wherever that corner down there where that red circle is. And so that blue circle is where it's over 160 C, and that's over on the ceramic. Right then it wasn't that high on that one, but then this one, oh, this is just the ceramic. Yeah, that's over 160. Maybe it's not the fan that's that hot. I'll probably test it again, but at least I know they're getting hotter. If my chamber gets over 160, I'll be happy. But I don't think it will, but you never know. I mean, I am insulating it pretty thoroughly. I'm using 2 panels on the windows, on the side windows. I may even do the front door window and the top window as well, a second pane, and as well as the back 2 filament chambers. I'm probably just going to insulate it right over that, because I'll have a runout sensor with the new electronics. So this can be removed from here. Wow, those are still very hot. These work really well. So this power source was like 35 bucks, and the heating elements are between 10 and 20 a piece. So depending on what amperage and voltage you get, or wattage, however they measure it, that's what's going to make the difference in the price. So here is the camera that's going to go with the Raspberry Pi. This is the Raspberry Pi and the touchscreen. And then I have to put the heat sinks and the fan on it. Oh, I have another fan. That fan is already installed. And then the Bondtech extruders over here. I'm waiting for this thing to finish printing, which it's making pretty damn good progress, and it looks like it's coming out pretty damn good. It's more than half done. And I did do supports in a couple areas, because here, I'll show it to you how it's coming out so far. I just noticed that you guys can't really see what I'm looking at. Right. So hopefully now you can see. I mean, it's coming out pretty good. It's 56%. So, and then you see the temperatures. 300 and 120. It's as high as it can go, and it's about 50 in the chamber, which is going to be able to get over 60 now once I put the heaters in there, because like I said, I have the transformer already over there from the lighting, so I'm just going to use that for this. And I'll probably put the lighting on just like a regular wall outlet 24 volt transformer. Okay, so I don't need that. Oh, this did come with that. Maybe that's what this is for. This can be used as an on-off switch and power, and how much power you want to give it. Where would this plug in? Where is it? Excuse me, I'll show you if it is for that. Oh yeah, I think it is. Okay, let me bring it over. So where this dial is, this same plug goes to that dial. Where that dial is, this is just a replacement for it. But does this click on and off? Oh no. So you know what I have to do? I have to get another one of these, if I may have one, that goes all the way down and then clicks off, and then goes all the way back up, so that I can shut it off right there with having a switch. But then I'll also put the remote control outlet by either using Z-Wave or Wi-Fi. All right, so that's for one printer, and then I'm going to make longer cables, and they're going to go over to the QI-DI printer, and they're going to add the same setup, one of each of those. But for now, I'm going to leave that here for now until I try to find another one, and just have the wiring available. But let's take a look at this Raspberry Pi directions. I have to grab an SD card. I have plenty of them. Excuse me one second. So I'm not going to put a 128 or a 256 gigabyte card, and even 32 gigabytes I think is overkill. I'm going to put a 4 that I had. Oh, I need the adapter so I can format it. It may already be formatted, but I'm not sure, so I just want to check. Oh shoot, I do have a reader on that desk. That's all right, I'll just use this adapter. This laptop this is a Surface Book Pro. It's a Surface Book Pro 2. It has the port for SD cards, full-size SD cards right in it, so I don't really need the adapter, but I think this one takes micro SD cards in it. Yeah, it does. All right, check File Explorer, see what we got. Where the heck is it? No, local disk C. It just beeped when I put it in. What the heck? Maybe this adapter's not working right. Let's try it through USB. It beeped with that, and it beeped twice. Alright, it should get it. Maybe that SD card's no good, I don't know. What the heck is that all about? Alright, let me grab another SD card. I have these like crazy high-end 128 gigabytes, but they were filling up pretty quick with high resolution videos, so I got some 256s for the cameras when I do these videos like these. These are the ones you need for video. But I think this is going to end up with a 32 gig, and this card is for camera video, so it should be plenty good for this. Come on, you're in there, right? Let me check device manager. D, incorrect function. What the hell? Device manager. Disk drives. And that's. Okay, is that my? I don't remember what brand my hard drive is in this computer. But neither of these are Toshiba, so it must be a Toshiba. My solid state drive that's in here. It goes to my wireless network, which goes to my 16 terabyte MyBook, which is a good investment if you guys have a lot of stuff saved on computers. It's one of those big external hard drives. It was like $300. It was kind of expensive, but it's not an external solid state drive, which I do have one of those too, but it's only 2 terabytes. If you need a lot of storage, like 16 terabytes, this thing might end up getting a freaking 128 just because I don't have anything else that's cooperating. I know I do have other stuff, but I'll have to find it, see what's going on with those. They're probably formatted in a way it can't read. I have to format them on whatever they were in. Where's my damn lighter? There we go. Why aren't anything showing up? Maybe that adapter's no good. No, there it is. Okay. This one? Incorrect function. Alright, let's just do format. Hopefully nothing important was on it. It's not really doing a format. I think this USB dongle might not be good. Let's try the 32 in this. Sorry about this, guys. Obviously, this is not something I thought I needed to test before I did a video. And then I got this super long cable for the camera, because when I saw it in the picture, it looked like this camera belt cable was very short, and obviously it is. Okay, I think that just slides out. No, it's got to have a release. Let me grab my little tweezers. See where this releases. Oh, and I think it's this part right here. Yep. That just pulls out, and then it can come out. So it was facing this way. Okay, that's in. And then this can go to the Raspberry Pi. Yeah, I'm gonna have to try, it's not working on here either, so I'm gonna have to try the 128. And then if that doesn't work, I'm gonna have to use my good 128, and I'm not gonna be real happy about that. Or I may just go try it on my desktop. That's probably what I should do. Yeah, let's do this on my desktop. Let's take all of the ones I tried, and I'm sure one of them is going to work over there. I'll bring you guys with me real quick. Okay. I'm not going to go to my office desktop. This is a pretty powerful computer right here, this desktop, but the one on my office is kind of crazy. I replaced so many parts. I've got it up to 128 gigs of DDR4 and an NVIDIA RGX 3070, and what else? The graphics, that the hard drive, it has 2 hard drives. Problem, scan and fix. Yes, okay. Repair drive. That's why. It's got a 1 terabyte solid state drive. I'm sorry, 2 terabyte solid state drive. Oh, this is the ATN file. I don't want to delete that. All right, let's take that out. That's from the new scope. I got the new 5G one, or like the true 4K one, the version 5 or whatever. It actually is way clearer than the old one, but I don't like that they didn't put a knob on it. The knob was helpful for zoom and whatnot. Now you just use the forward and backward arrows. This has a lot of hard drives on it also. Data D, recovery, elements G. Let's see, what's that? Oh no, that's another cordless. So this is a plug-in solid state drive. This is a plug-in regular hard drive that's actually plugged in, which is what I was just looking at. I'm going to take that out. And then I have a flash drive plugged in. Yes, let's scan that drive that has a problem. That's got to be what it was. Is it? Maybe not. And then this little tiny SD card, if you can believe it, is 1 terabyte. This one right here, 1024 gigabyte. It's insane that they could make that much storage on such a little SD card. I don't think it came up. It didn't. I don't know why that one's not working. It's not locked. There's something wrong with that one. Let's see if I can get the 4 gig to work, because that's the one I wanted to use in it. Actually, I don't know why that didn't come with an SD card. I believe on the order it said it did come with one. So maybe I dropped it or something. I don't know. Or maybe it's still in the box. There we go. That one's working. Which one is it? Let's pull Device Manager up on here. Disk drives. That's the Samsung. That's the one in here. SD card. Okay, let's right click and do properties and try to format this. Remove a policy, better performance, enable right caching. Okay, we're gonna do all that. Driver, okay, let's go, okay. Okay, no, it won't do enable rate, but it'll do the better performance, okay. So let's unplug it and plug it back in and see what I get. I don't know why it's showing up there and it's not showing up in storage. There's something wrong with the format of it. Update driver. Search automatically. Sorry about this, guys. This wasn't supposed to be part of the video, but I'm doing it as quickly as I can. Okay, yeah, I gotta install these two things. Probably one of them relates to that. Let's see, where's the optional updates? Advanced options. No, that's not what it is. There should be optional updates right here. Okay, I don't want a tutorial on how to check the PC health. Okay, well, the first one's almost done. So I'll just go show you what else I got going on over here while I'm waiting for that. So the insulation inside is done. I'll turn it on so I can get the light on in here. I just have to do the ceiling, and I have to just cut the holes on that side for the vent into the filament chambers, and then I'm probably going to even insulate this part and then cut the holes on the top for the chamber over there, for the filament chamber, but less holes because it's going to have so much more heat. And then I was thinking I would put the heaters up here on this side because this belt cable is only going to go to there, and then it's mostly over here when it's off. So I would put them right here, one right behind the other, so they're not that high. They're not going to hit the belt to melt anything, and I'll probably I may end up having a whole new belt on here. Let's go 100 centimeters at a time, 100 millimeters at a time rather. This thing is just so well built. That's why it's worth doing all this work, because the linear rails, linear rods, lead screws, it's very robust. It's a true industrial printer. So I put both high temp hot ends, even if not to use it for high temperature, which I don't really need these stickers on here. Even if not to use it for high temperature, it's for the thermal properties of the brass over the aluminum rather. So, and the extruder, I have to wait for that mount, but I actually may use a new stepper on that too. A more high temperature stepper, because I'm making everything high temperature inside here. I didn't get any kind of mount for this camera, but I'll probably just find something to print or design something to print. I'm not really sure about the placement on it. I'll probably go somewhere centered on one side or the other. This side doesn't have a stepper motor, so I would say that would probably be the best idea, but I have to figure out where I'm going to actually locate the Raspberry Pi. It may go all the way down to the bottom and inside the bottom at a later date when I get the main board, and then the screen will be in here. I'll be removing that one and putting this one in. It's much higher resolution. And then I do have the proper power source for it. And these actually connect right together where the pins need to be. So this would go right there. And that's connected. So it hasn't been flashed. I don't have the, well, they say flashed, but where is the SD card that was supposed to come with it? That I don't see. That was where's the box for that? I think that's in my office. Yeah. Let's see. No, this is the box it was in. Okay, I don't see anything else in there. Or in any of these foil packets this stuff came in. No, I don't see an SD card. I don't think it came with one. All right, well, and I got the power source with the switch for it, so that you can turn it on and off right at the switch. That's done. I just heard it on my computer, but this is going to get plugged in back there somewhere, and it's going to come right over here, probably right here. And then this is the power source for that. This is some extra insulation I may need for smaller pieces and silica, but Here's the Raspberry Pi, which, oh, I forgot the middle piece with the cooling fan. And I still have to put the heat sinks on and all that. So let me actually do all that before I fire this up. I don't actually want to plug it in until I get all the heat sinks and fans in. Let's see. Let me just check where that fan gets hooked up. I think the fan goes to. The fan actually goes to the screen. The screen supplies power to the fan, which means there's probably another one that's just for the Raspberry Pi. I mean, I'll be able to use this on Wi-Fi and with local area network just with this, which will be nice, but it's not my end goal, that's for sure. Oh wait, that's supposed to go through. Here, let me show you what I'm doing. I'm just running the wire for this, which needed to go through this little hole. I'll show you what I mean. Let me grab a small pliers. All right. I really need my tweezer pliers. There we go. These come in very handy, tweezer pliers. Oh, I just dropped a screw from something. Where did that go? Oh, it might have been stuck in the pliers, probably. All right, so this needs to go through this small opening on here, I believe. Let's see, where's this gonna go? It's gonna go right there. It's gotta go through this one. So I probably needed to relocate the fan. Matter of fact, the fan might be upside down. I didn't screw it in yet, so it's not a big deal, but so this needs to probably go through here, which it doesn't exactly fit all that well. Well, maybe it can go right through there. And then this can go on there. And let's see, that'll be right there. Yeah, it's got room. And then it'll plug in right there. Oh no, it's on the wrong side. Well, it still might work. Just have to put the cable over. And we'll use these to guide it in. Okay. All right, that works. So this is going to be in the middle of the two, and then this is going to go onto here. Then there's your pins, and this is going to, the fan, oh, actually, no, that's wrong. The fan needs to go right up here with the screen. I'm on the wrong side. Well, that's why it didn't fit through. It doesn't need to go through. Sorry about that. I haven't put one of these together before. I mean, I have put together a lot of computers and done a lot of stuff on computers, but I haven't put one of these together before, the Raspberry Pis. So wait a minute, that doesn't really add up. The fan does go on this side, that's for sure. No question about that. But the fan needs to be on that side. Oh, well, yeah, no, this has to have this on this side because it's got to go deeper for all these outlets. Okay, now that makes sense. Okay, and then this goes right here, and then it can plug in there easily. I'm not going to plug it in just yet, but this can go there easily, and then the screen, I guess, just goes directly on the outside on top. Is that right? No, it's not. I don't know what I'm doing wrong. I don't do this very often, but where are the directions? Oh, this is perfect. Just a little card that shows, oh no, this is for the Raspberry Pi. No, that's not gonna help me. It's one of these little books I just got. This is it. Okay, oh, this is just telling you what to do with the SD card that doesn't come with it. Yeah, the micro SD that was supposed to come and didn't. Okay, it gives you the address of where you need to get the software at least. And everything else was for the power sources and old stuff. So I don't think that came with any more direction than that. Well, here's the thing. I ordered 2 by accident. I don't know how. I must have hit the button twice or had put it in my cart twice. But yeah, no, that's literally, unless there's something more under here, this is the exact same thing. And that's the way it comes with the housing and then the board and the instructions. But I'm not going to be keeping this. This is going back because I only needed 1. So this does probably need to go underneath this part because that has the opening for the screen. So maybe that center part does not go in there when you're using this, but then where the hell does the fan go? All right, you know what we're gonna do? We're gonna pull up my Amazon account and look at the look at my orders and see what they have to say about this on the site. Let's see. See that last extruder has the tensioner on the other side, and that comes in on Monday. Okay. So I still have a couple things coming in today. It's ridiculous to me, but they come multiple times in one day. Where am I? No, that was delivered today. What am I doing? I went right past it. Right here. Okay, let's see. Install the Pi on the heat base and install the heat sink. I didn't need heat sinks. Installing the fan. Yes, okay. Oh, the fan goes right on the back of the screen. Where? Oh, hello. It does go right on the back of the screen. I don't need that part. So I guess that's if you don't use the screen. So I'm a big dummy for that. Okay, so you want the letters facing out. That's all I needed was one picture. What a dummy. All right, let me take these little things off. Or maybe they need to stay on. Maybe that's how it stays tight. Let's try it. And this is a small Phillips. I'll just use my manual one right here. Well, I guess that's not supposed to stay. Let's just make a hole in it with my little precision tweezers, and that ought to do it. And then I can get the screw in, and it'll act like a Teflon tape to make it seal better. Okay, boom. Now my screwdriver. I'm definitely going to get my little electric micro screwdriver. Or battery operated, whatever. There we go. And that is definitely going to screw it nice and tight. Now let's get my little power screwdriver and a small Phillips. I'm sure I'm going to need a 1.5, a 2, a 2.5, and a 3. That's not quite the right size. It's probably more flat like this. Yeah, that's the bigger one than I thought, but yeah, that's it. Definitely it. Okay. Then I have 3 more screws for this. Okay. And then 2 more, and then, yeah, so it goes the way I had it. It just doesn't need that middle piece. Apparently that's if you're not using the touchscreen on here, and maybe if you're using it somewhere else, which might be what I'm gonna do later when I put the which I'm sure there's a cable I can buy or even make, pull it out of an old desktop and use it from those pins to these. And this screen, compared to the original one, is it's a little bit smaller. Yeah, I'd have to get another screen. All right, so this is going to go back in here where it was. And which side should be open? Is there something on one side to access? I don't know, maybe those cables? I don't know. I don't think there is. Oh, it's for the fan, to get some air. That's what that side for. Okay, and then also, yeah, the fan needed to be on that side, which also gives me a fan for the Raspberry Pi, which is great. Okay, fantastic. That's put together. All right, so all I need to do now is to flash it and put the SD card. Oh, well, once again, I forgot to put the heat sinks in. That was brilliant. So I'll bring you guys back over here. I'm just gonna check the picture of where the heat sinks go on the Raspberry Pi, which is actually right there. Oh, and then my camera wire needs to go in there. Ah, it goes the other way. That's where the camera wire goes through. But then that's not going to fit. No, I can't do it that way. Well, I guess because the fan, it won't work that way. So I guess the ribbon cable has to come out, has to come up and over, and then out over here. So I guess that's another good reason I got the extension. So this is going to have to come through here and go right up over that fan connection. No, that'll put it right over the fan. That's not going to work. There's got to be another way to get this in there. There's not a top or a bottom opening. Oh, well, I could put it through here. I believe. There we go. And then actually, I think I'm going to end up connecting this to the Raspberry Pi. Let's look at that too. All right, let me do the heat sinks first, one step at a time. Okay. Heat sinks. All right, now these go onto each of those 4 boards. So let's just take the adhesive tape off. So I've never done this before, so I'm sure some of you could probably tell that right away, and some of you maybe can't, because I am prepared to do this type of electrical work because I do stuff similar to it all the time, but I've never done this. I've never used this small Linux chip and hooked it up to a 3D printer. This is the first 3D printer that I bought that's, you know, an industrial printer and has a lot less of the modern features that I had to update. So that's why I haven't done it before. But I do a lot of low voltage stuff, so this is frankly very easy. You know, a picture and I'm good. I just need to see what it's going to look like finished, then I can do the rest. Because I know how to check voltage and continuity and et cetera, find diagrams and read diagrams and schematics. That's all stuff that I've been doing in a long time. All right. this is gonna go this one direction, and on top of that chip, boom, done. So that's the heatsink setup right there. That's how they go. And the two tiny ones on those and the two bigger ones on those. And then the camera, the camera actually goes to that, and this goes to the display, which the display is plugged into, where do I connect to the display? Oh, so that little ribbon cable, what's this board? How does this board connect to, oh, this is, I don't think I need it. That's if I want another display. So this needs to go to the camera connection, which is not going to be convenient to get this thing out of here. Well, actually, if this is going here, it would still be over the fan though. If I put this in here, and the pins need to be facing that way, so I could put this in here. Oh, well, that screen's actually going to move up a little tiny bit, but that's not much of a help. I just don't want to block the ventilation from the fan. Well, I guess I'm only blocking a small section of it, and then this has to go into that, and then I'll be all hooked up. All right, let's pull that lock up so I can get the ribbon cable in. Okay, and then the pins face this way. So let's put this in. No, that's on the wrong side. I need it on the other side. Damn it. Okay, so that's going to go right from there, over here, into there. There we go. Okay, that's in. Now we got our camera hooked up, our screen, and our heat sinks and fan, and Raspberry Pi is just about good to go. Just need to figure out where it's going to go and where I'm going to place the camera. Just want to make sure that these are in right. Okay, that's perfect. Okay, now I don't have to open this thing up again for the foreseeable future because you can access the SD card from outside. And I think that's about it. I don't need this piece because I'm not doing that. These are the cheesy electrical connectors that it came with that are not heat shrink, which I don't like. And that's about it. So pretty much what else I needed to do is done. The additional heaters, which I've already showed you one, so the rest are exactly the same. The only difference is, you know, you're hooking up 2 and 3 out of 1, 2, and 3 on the output of the power supply. So I guess that's pretty much it for right now, because the BMG extruders I'm not going to be doing until I get that part finished. I might do the one. If I do, maybe I'll include it, but if I don't, then I'll probably do them both on Monday when I get the other one, after I get done with work. So I'll bring you over here, hopefully this, okay, restart, yeah, of course, how you do. And this thing is looking pretty good. 87% done already. This is the super high temperature nylon. I don't know if I mentioned that. It's called PPS. We'll restart anyway. I'm sure that I used that in something else. And this thing did come with a little dial so you could focus. You could use the focus because it's so tiny. And also I'm going to try to see if there's an STL online to use for a mount for this. Otherwise I'll probably just design one real quick on Fusion. Also guys, I do custom 3D printing work if you guys ever need anything. I do you know, I can do the design for you. You can just tell me what you need, or you need a part for something. Like if you send me to something that it needs to go to, I can make sure that it fits perfectly. Or if you're confident in the measurements, if you could give me measurements like to the thousandth of an inch, I can make just about anything, whether it's CNC machined, turned, on the lathe, or 3D printed. Especially now with the industrial 3D printer, I can make it in PEEK, I can make it in PEC, I can make it in Ultim, I can make it in any of the PPS, the PPSU, all of the high temperature thermoplastics I can print with. That I'm just modernizing and modifying to be the most capable printer I can get it to be, which I believe that printer can be incredibly capable, because the design, the structure of it, the build of it is far superior to any other industrial printer I've seen anywhere near that price range. So therefore, I honestly think if they did these modifications and sold it for 6,000 or 7,000, they would be killing it. They would be really killing it. And I offered to share any information I get by building it with them, anything they wanted to know, and they did. They were very, very willing to help. They surprised me, because I had read that the support wasn't great, but I wasn't expecting it to be great, because QIDI turned out to be the only company that had great support, after sales support. And in the beginning I thought they were bad, and they were actually really great. They had a lot of issues, but they helped me fix every single one of them, had a fix for every single one of them, and provided the parts to fix every single one of them. So I can't fault them. We all have mistakes, especially when a product's new. I mean, I've had my share of mistakes, you know, on jobs, and I make it right. And that's all I really wanted, was for them to make it right, and they did. So I have nothing to complain about. Now this is when I was looking at the printer. I mean, it's a PEEK capable printer the way it came. I'm just making it a much more PEEK capable printer. Let's see what we got here. Hopefully that SD card is showing up. Well, let me go get those flashing instructions for this. Let's see, is it here? I think, is that it? USB storage? No, that's the network one. Data D. That's it. Oh, I had documents backed up on here, and a video. Oh, this is iTunes stuff. So let's see if let me make sure that's it. Unplug it. Data. No, that's the storage hard drive in the computer. This is a all-in-one. Obviously, it came with one solid state drive and then one storage hard drive. The storage hard drive, I think, is 6 terabyte, and then a 1 terabyte solid state for operating. So it's still not showing up. Let me go back to Device Manager. And actually, I'm going to just take a walk into my office real quick. I'll be right back and try to find another SD card that will work without all this stuff, so I don't have to make you guys watch it. Because I just wanted to show you the process of... Matter of fact, I'll end the video here, and I'll bring back another clip after I finish printing this part. I'll show you how that's going to fit and decide whether to do one extruder now or both later. And I will show you how to do this process of flashing and then installing the proper firmware on the Raspberry Pi. So I will end it here, and I will be back in 1 second for you guys later. Hey guys, what's going on? So back to the Creatbot, and I kind of got a little carried away with how far I'm gonna go on it. I have a tendency to do that when I get into something. I get like all the way into it. But this Raspberry Pi, I didn't realize how in-depth setting it up was. It's kind of a lot of actual manual coding. So this is installing the desktop for like the third time that I've had different different versions of the operating system installed on it. This is the Octoprint version, the one that I actually need to use the Octo Dash, so that the 3.5-inch screen that goes with the Raspberry Pi will work as a controller for the printer, so that I can use it with Wi-Fi and I can send prints to it without having to take the SD card out and all, or the USB stick, whatever. But the printer is pretty impressive. You can see it's printing right now. This is what I'll show you when it's done. It's an overhang test. This is, in the previous portion I showed you one of these that had fallen apart because of all the heaters I was adding, but this is a small bird cage, like a thumbnail sized bird cage with a little bird inside, and it actually comes out with pretty damn detailed for something this small. I hope that's focusing in okay. It's kind of hard to tell, but there's a tiny little bird in there, and it's pretty good quality for being so small. So it's printing the overhang test right now. It's going to look like those other square ones that I had. I believe in the other in Tamp's video that was a nightmare. I don't even want to remind myself of, but it's pretty good. It's working pretty well. It's pretty impressive. I haven't done any high temperature stuff with it yet. I'm going to let this print finish, and then when I come back in the morning, I'm going to start it on some nylon. So I'm going to let this overhang test finish, and then I'm going to do something in nylon, and then I'll probably go to the PPS, the really high temperature nylon, which I used for there's an adapter for the Bondtech extruders. I got the two Bondtech extruders that are left and right for the two sides, that where the tensioner screw for the filament tension is on either side, so that they'll be on opposing, they'll be on the outside of both. So I have the other extruder coming in, the second one. I took this apart. I took the whole tool head apart with the mount for the two extruders and the two nozzles. And I mean, the adapter, it all kind of makes sense, but I have to see it go together. The one that I printed in PPS, that really high temperature nylon, I'm not really all that happy with, because it didn't stick completely, because the bamboo was at its highest temperature, and it's still, you can see it's like curved, because the bamboo just wasn't hot enough for it not to warp. The adhesive worked really good. It was really stuck down, but it just still warped. This stuff is incredibly high temperature. It was at 280, or the nozzle was at, 260 was the factory setting for, I don't remember which setting I used. It was like it was one of the high temperature ones, but 260 wouldn't melt it. I thought it was clogged. I took the nozzle out, and there was the whole piece of filament in there, not melted at all. So that was 260 degrees Celsius, and the filament was like rubbery at the bottom, but it was not extruding at all. So it's really, I mean, it's supposed to take up to 180, that like tolerance wise when it's finished. But I mean, after seeing that, I got a feeling it'll probably take more than that. It might soften a little bit at 180, but it's not going to melt until 280. So it's pretty impressive. So I mean, they do compare it to Peak. It's not really nearly as expensive. If you guys are interested in some high temperature stuff that's not crazy high temperature, actually, I don't think it's actually comparable to Peak. I think it's probably, see, this thing is still going. I think it's probably somewhere closer to that realm, but I don't think you're going to actually get that high temperature without getting that high temperature, which is why I'm going through all the trouble to do it. And I even thought about doing water-cooled backing plates on the stepper motors, which I still may do. I have to see how far I get in this build. I have the new motherboard coming in, and stepper drivers, and I've been communicating with Creatbot, and they've been good about helping me out. They told me what stepper drivers are going to work, and they're going to get me some information, and I'm going to get them some information. So hopefully it's a mutually beneficial modification to the printer. But I'm looking forward to seeing what it can do when I get it where I want to get it. I just wanted to have one really industrial level, very high temperature capable printer. The Bamboo Labs are definitely still the go-to for everyday, you know, quick printing, because that's not going to print as fast as these. It's not meant to, but it's meant to print like really high quality and really high definition. So when you need something really done right, really perfect, and in a really high temperature material, or a higher temperature material but very precise, that's the one I would use for that. So anyways, this is still going. This is taking kind of a long time, but I guess it has every time. I'm just keeping myself busy with other stuff in the middle. So I won't bore you guys too long on this. I just wanted to put an update on this video, the Creatbot modifications, and we'll see how it goes. I don't know how long I'm going to make the video. I might make it shorter and then update it later, because you know, this may take some time, but I'm going to put the unboxing up, and then I'll put a shorter version of the modifications up. So if anybody has one, because there is not a lot of stuff online about this printer. There's more about the Intamsys. There's more about just about any printer, but the Intamsys pales in comparison when you have them both in front of you. If any of you guys have seen them, you'll know what I mean. This machine is much more industrial and bulky, and like, I mean, they just had an X and Y, one single rod, and this has a linear rail going across, a linear rail on each side going front to back. It's just a much more industrial machine. It's built way better. So only thing I would change is I never would have got the Intamsys, because it was, I mean, I don't want to trouble anybody else with having to return it, but also, you think I want to have to bring it down here and set it all up and then have not one single successful print, and then have to bring it back and to send it back? It's just been a pain in the neck. But anyways, this one is turning out much better already, and I mean, just the fact that it printed right away. The direct extrusion, I knew it was going to make a big difference, and it did. So that's all I have to say about that. But anyways, I appreciate all you guys watching, and hopefully somebody else that's looking for the Createbot videos like I have been will find one more, and it'll hopefully give them some information, because the more I get, the more I'm going to add to this video. All right, thanks guys, later. Hey guys, what's going on? So I'm just continuing my my build video for this Createbot and making it a higher temperature machine than I bought it as. So at this point, I've insulated the inside, which I'm going to end up changing and, well, adding to. I'm going to keep this insulation. I ordered some adhesive insulation that is like a layer of foam, and then it's reflective. It's basically what comes in the other high temperature printers on the inside. I ordered a couple of 2x4 sheets. 2 foot by 4 foot pieces, so I can cut it to size for all these sections, and then I'm probably going to put this on top of it. And the reason I'm going to use this on top is because that stuff is going to adhere right to it. So I think it's going to actually help quite a bit. And then this is the plexiglass that I'm going to double up the windows with. Well, this is the diameter of it anyways. I'm not going to use this piece because it's shot, but I have a new couple foot piece that I'm going to use. And I'm gonna that's the shape. I'm gonna probably, I may just put it in the CNC machine and cut it manually with the remote, or maybe I'll write a quick program for it to cut it. I'm not sure yet, but I did do liquid cooling system. So I did make programs for. I'm gonna take the camera off real quick. I made programs to machine these aluminum blocks that go on. So there's one on the back of the motor, of each stepper motor, on the extruders, and there's one on that stepper right there, which I only did that stepper, and I put that metal zip tie, and instead of making it adhere with some thermal grease in between, because I'm replacing the stepper motors. So just until they come in, but I'm going to be putting in LDO, the super speed, high torque, high temperature motors. So it's printing a Benchy right now. I'm seeing how it works with that hot end. I got a different hot end on it, obviously. But I still haven't even used the high temperature side. It'll be the first time I use it when I use it, because I'm doing all these modifications before I even print any peak or anything with it, or Ultim or PEC or whatever, because I'm eager to see what. Well, shoot, that just stopped sticking. That's not good. See, one second it doesn't stick and everything's a mess. If I wasn't here, well, now I have this. So I set up a Raspberry Pi. I'm sure you saw in the previous part of the video. I got a screen for it. First, I got a 3.5-inch screen, and then I decided I was going to go 7-inch because it was so hard to read everything. But now it's nice and easy. You can't see right now because it's not plugged into the printer, but I'm still in the process of setting that up all the way. So I haven't put the stepper drivers in yet, or the main board, because I haven't put them in because sorry, I'm multitasking. I haven't put them in because I haven't gotten the new steppers, and because I'm not going to program it for this and then change the steppers and all that again later. I'm just going to make sure I have everything the way I'm going to have it. Get the high temp steppers. They're not very expensive, honestly. The high temp steppers, like for the high speed, high torque, high temp, like $30 for the X and Y each. So like $60, and then like 20 for the extruders, so another $40. It's like $100 for X and Y, and then the Z-axis is not even in the chamber. So I mean, because of the speed, I could have, but Z doesn't need to go fast. It's not really going anywhere. It's just going up and down very slowly. So I mean, I'm gonna check into what, because maybe the 0.9 degree step instead of the the 1.8 would be better for that, just because it's the accuracy, because the 1.8s are actually better for speed. I'm going to try to use this nanopolymer adhesive instead. The thing with this printer is if it doesn't stick. Oh, and then I had to move the Z-axis up. I have to set that. It has to go up a little tiny bit. No, let me go back. I need my... I haven't even looked into that yet. Let's see. Alright, Z home. And then what I do is I have this, one of these is a 0.2 and one is a 0.1. So I put both of them, because at 0.2, oh yeah, that's a little high. I thought it was. Okay, where's my 3mm? I'm gonna have to do that again, but. So an easy way to get this tool head at the right height, because these tool heads, the nozzles go up and down on the two for whichever one you're using or which one you're not using, unless you're using them both. Then they would be at the exact same height. But so when I home the Z, it's gonna go up to the X and Y real quick, and then it goes back to Z. And I just drop this down below where I want it, where it's gonna end up having to be, and I leave it loose, and then when it homes Z, it'll force it up to, that's 0.3 of a millimeter. So that's about where you want it, because it's now, if I just go all the way to 0 on Z, I'm gonna just barely feel it on this 0.1 spacer. The 0.2 will be, difficult to get in there. So that sets it right where you want it every time. I just must not have tightened it all the way last time, or maybe I did something else and didn't do it and didn't remember. But I mean, I've got another print going on here. I'm always multitasking, so that stuff happens once in a while. But anyways, the liquid cooling system is working fantastic. So these are the blocks. Hold on, let me show you real quick. These are the blocks right here that have the aluminum. There's one on top right there, and then there's one in the back. So I made the holes. I made them a couple diameters, a couple thicknesses, and I made them a couple different you know, I'm gonna, in the end, when I put the new steppers on, I'm gonna have one on the top of the two extruders, one on the top of each extruder, and then one on the side. I mean, rather on the back. It's gonna, technically it is the side, but it's gonna, one on the back of the extruder, and one on the top of the extruder on each motor. So, and then on this motor on the side, that's the what is that? That's the x-axis motor. The x-axis I did an aluminum heat sink. I ordered a couple of bigger aluminum heat sinks, and then I put the liquid cooler, then I put the heat sink, and then I put the fan on top of that. So this stuff is all like, you know, if you buy any industrial, like purpose-built Peak 3D printer, like their $14,000 or $15,000 printer that's a Peak printer, it has all that stuff. It's liquid cooled. I mean, anything that's gonna print in an oven, you gotta have some way to cool it. So, and cooling hot air with hot air, it's too hot. A fan's not gonna do it. So you need some way to actually cool it. And aluminum transfers heat very quickly. It cools down fast, but it heats up very fast, like when you're cutting it or machining it. It gets very hot, hotter than steel, but it'll cool down very quickly. It's almost like the opposite of inertia because of weight with steel. You get less with aluminum, you get more heat. So here's the temperature inside, if you guys can see that, yeah. So right now it's pretty low, but if I open the door, you'll see the real temperature, which is, yeah, it's already over 60 Celsius, or in the 50s anyway. So I have the two of the 4 heaters that I got to install on a separate power source. The other 2 I just didn't install yet because I have to take the first 2 down because of the insulation. So why do it again? But what I did is I put the heaters on little aluminum welding coupons like these. Where are they? Like these right here. So this is what I used. Oh, excuse me. All right. There we go. Okay, I used these, and then I mounted them to this, like this, for the ceramic heater. Right, so it's through these 4 holes on that, so that it's up against the metal, not the insulation. And these are 24 volt, 300 watt. They put out a lot of heat. Those things get over 160 Celsius coming out of it. I don't know how far because it doesn't measure higher than 160. Well, now it does. I changed the parameters on the camera, so I could probably tell you looking at it now while it's on. And then this is the power source for that, and you can adjust that dial and set what power. And then I also have a grid heater in there, which I made 2 aluminum spacers, which were out of aluminum bar stock. I made them more narrow on the lathe, and then I spaced it out from this and put another aluminum block behind it, and then those are sitting. So this is behind it, and then this is sitting on 2 risers. Like, I think I have it like this actually. Yeah, I do. And then I have the two spacers with a long screw going right through that holds it all together. So, and then it obviously has some space back here. That's what the spacers are for. Did I do it? Oh no, it goes this way. No, it does go that way. Anyways, I'll show you inside there when we get back. But and then this is the cooling system. So this, I happen to have one of the several air compressors that failed, that I blew up. The air compressors, I blew them up because they just couldn't handle how much I was giving them, and that's that simple. So one thing about this that I'm going to be happy to get rid of when I have Klipper on here is that it does this thing where it does the little space of line, the little line to test the flow, and after it does that line. Oh, well, the inside chamber was down, so the main heater was off. So it does that line on the front of the bed, and then it shuts off and waits for you to press play for the print. I don't know why it does that, but when I get the new firmware on there, it won't be. Anyways, that's the radiator from that and the reservoir from that compressor and the pump. And then I just printed out a box for the switch and ran the wiring, and that is all 120, so I didn't have to use a reducer or anything. Where is that water coming from? Hold on, it's leaking somewhere. It's coming from the radiator. Where? I gotta figure out where that's coming from. Anyways, it's working fantastic, other than the leak I just discovered. Let me put this over there until I can fix that. But yeah, it's a good cooling system. I'm gonna fix that spot, and then that's it. It should be good to go. I just have to weld something when I was taking it out, or I'm not sure what it is, but I'll find it and fix it. And then that's about it. So the new insulation I'll be putting in, and the new stepper motors, high temperature stepper motors, and then once I do that, I'm going to put the new main board in and program the new firmware, and then I have a Raspberry Pi set up with Octodash, and it's coming together. So I figured I would just give you guys an update and let you see how it's coming along. So I did get a chance to look into the electronics on it, which are outdated and cheap Chinese electronics like you'd expect, which is why I'm updating everything. The power source, I may even put a new power. The power source that I got is actually pretty good. It was fairly cheap. It was like $40, and you can adjust the power on it. I would have to get something with a set power, because I don't want to have the adjustment on there. It needs to have a fixed power, and then it's regulated by the drivers and whatnot. But they're actually the updated stepper drivers. I'm sure I probably showed it in the beginning of the video, because this is, like I said, it's going to be quite a few part video. I'm just going to do updates like this, and then I'll include the important stuff. But setting up the OctoPi, you guys, the Raspberry Pi, you guys had a clip of it before in the video. It's more intricate than I expected, and it brought me back to when I was a kid and computers first came out with DOS and having to do coding. I never got really into coding. I know how to do it, but I'm not like a connoisseur of computer coding, but I can definitely get by. And I did. I got it programmed. I got everything working. This is the housing for the 7-inch screen, and the Raspberry Pi is printing right now on the QIDI printer, which, by the way, they have continued to impress me. After my first impression was terrible with them, my remaining impressions all the way to current have been outstanding. Their customer support has really, particularly the one woman that I dealt with, Olivia, she was incredibly helpful, always sent video. Like, I didn't need the videos on how to install this stuff, especially that's a very easy printer if you're technically and mechanically inclined. It's not very difficult to work on, but the fact that they sent them, it just shows that they're prepared and they're ready to go out of their way to help you fix it. And they sent the parts that I needed. They sent more than what I asked for, and they sent, like updated parts, whatever they had modified on the printer from customer feedback or from trial and error. They sent me that stuff to update on it as well. Which the only thing I don't like is I manufactured a hot end for it. I mean, not manufactured. I manufactured some of the parts to put it together. Actually, 2 of them. So I made this Creality hot end fit for the QIDI printer. This is their heat break throat that would fit right into that heat sink, and then also this is another large block that is also obviously on one of their heat sinks, on another one of their heat throats. These are from tool heads that broke, that the ceramic cracked, which, by the way, they sent me 2 new tool heads, 2 new hot ends, because they had cracked under temperature, and it was obviously under 350, because that's all that will go up to. But I was printing PPS, and it's a high temperature material. It was up there, and they cracked 2 of them, and they sent me 2 new ones. So, I mean, even as something as insignificant as a tool head, it's not insignificant. It's $40 a pop. So it's really impressive how much they stood up behind their word after my bad first impression. But anyways, the Creality is coming out great. I'm waiting on the additional materials. It's been a little while, but it's not something that's going to happen overnight. Probably in the next few weeks to a month, and then I have shooting competition coming up now starting. So I'd like to get this finished, but I doubt I'll get it finished. It's a month and a half away, but we'll see how it goes. Time is of the essence as well. Like I have a lot of other stuff going on, but we'll see how fast I can get this thing finished. But I will definitely keep you guys updated. And here's a benchy that came out of it. It's printing incredible, actually. I mean, it's almost seamless. I mean, the smaller parts you can see more where the movements are, but I mean along the wall it's pretty clean. If you guys can see that, it comes out really well. The printer's doing amazing. So along the doors, I'm going to find a way to seal that. It needs to be something thin because there's not a whole lot that I can put in there unless I put a bigger magnet or another couple magnets maybe. I'll probably put a couple more magnets and make that have a little more oomph when it closes to make that seal. And then I'll just gap it around the magnets. But anyways, I'm going to seal that and seal the top door. That's the only thing the Intampsys did have over it was the insulation, and I think that's why it had a higher temperature, because it had the same insulation that I'm going to use, similar, not the same, but very similar. And it had the latches on the door that sealed them shut because they did have something on the edge of the door, the lip of the door. So when it shut, you had to turn that latch to secure it, and that made a nice seal. So that's what I'm going to do on here, because you can see when I bring the thermal camera over here. Let me just grab it real quick. I had to wait for it to turn on, but I'll show you. The heat around the door is the hottest spot from the outside. It gravitates right the hot sensor. So there's a circle for whatever you're aiming at, and then there's a hot and a cold circle, the red and the blue. So the red is going to always jump to that crack in the door. Well, except right now it's looking at a heat source, but it's going to always go to that crack in the door when you're in a general area like up here. See, it's right at the crack in the door. There's the hot right there, right at that crack. It just jumps right back to the crack in the door. See, right at that crack in the door. It's always going to the crack in the door. Let me see if I can get a better read on this heater over here now. Well, it's 142 Celsius, 144, 196 Celsius, 214, 227. Okay, so that ceramic heater is putting off a lot of heat. That's 227 degrees Celsius coming out of that. So one more of those on the other side, and to make it, and that'll even it out also. And one more of those on the other side, and another heater on the other side, and then I have to get high temperature fans because the fan died on that from the temperature, I think. So I'm gonna get a couple high temperature fans that'll fit to replace the original fan on that grid heater. But the grid heaters are still working. The grid heater is still working fine. It's just the fan not working kind of kills it because it needs to work. And also the heater, the original heater that came in it. Once I change the firmware on the motherboard, it's going to be able to continue giving heat until it's 90 degrees Celsius, or I'm probably going to set it to 120 Celsius, maybe up to 150 at the most. I got to see how it does with the new insulation, with the second panes of glass, which is twice the thickness of the first, or plexiglass rather, and with the higher temperature stepper motors and how they're cooled with the cooling system. Once I fix that. And once I do all of that stuff, then I'll know what's going on as far as temperature. Once I see what it can retain in the enclosure, if it can consistently be at 140, I mean, I'll have it higher in the beginning because I need to see how high it can go and stay that temperature. But if it can get to like 150 and stay there, I'll set it to 150. If it can get to 120 and stay there, I mean, I'd be happy with 120 because for the price that I paid for this and then all the stuff that I'm doing to it, it's still going to be less than the Intamsys. And my temperatures are going to be significantly higher than the Intamsys. Those are 90 degrees in the chamber, which this one was 70 when I bought it, and it's still 70, but it's 80 in the chamber right now. So I can definitely get it, and it's consistently 80. I have it up all the way, and I do have the other heaters on, which there's only 2 of the 4 I'm putting in, but it's going to probably get over 120, I think, with another layer of insulation and all the other things that I'm going to do to seal up that enclosure. I don't see why it's not going to get to 150, honestly. But steadily and consistently, let's say conservatively 120 degrees Celsius. That's 30 degrees higher than the Intamsys. And then the bed, I'm going to be able to get to 200, no problem, because right now it's at 80, but just the ambient temperature, I'm willing to bet if I put a multimeter or an oscilloscope to the voltage coming into the bed, it's not nearly at capacity. I'm sure it's turning it down much quicker because that bed is aluminum and it's staying hot because the temperature in there is so warm. It's heating it easily. Like I said about aluminum, the heating properties is the same thing. Why it's absorbing the heat from the stepper motor so good, because aluminum absorbs heat really fast. So that's why all your heat breaks and all your the heat breaks that go on top of the stepper motors, all that stuff always is made out of aluminum. This is the ones that I ordered. My nose is running like crazy because the weather keeps changing. It was 60 degrees yesterday, and today we're getting a foot of snow. It's unbelievable. Connecticut weather. Where the heck did I put it? I thought it was oh, it's right here. So these are the ones I ordered. These I didn't make because it's honestly not worth taking the time to write the program for this, but they were like $7 for 2 of them. So obviously the $7 is not worth hours of my time doing that, or even 1 hour of it, or anybody's time really. Unless they're doing it on a massive scale and selling them for a profit, obviously, which is what they're doing. So anyways, I'm gonna wrap this up, find the leak in this radiator and fix it, and I will update you guys when I make some more progress. Once I get the new stepper motors in and the stepper drivers and the new main board and all that fun stuff. All right, so I'll see you guys soon. Have a good night. Hey guys, what's going on? It's Chris. So this F430 Creatbot, what's turning into a real build. I just wanted to make a conclusion to the first portion. Because I'm kind of at a standstill waiting for parts. Since the last segment that I made, I got all new high temperature motors, new LDO super speed high temp motors. These are all the new wires for them. This is for the X and X, Y, and Z right here. And then also for the extruder, I have 2 new motors for the 2 extruders, which I may only use 1 extruder. I'm not sure. I have 1 water-cooled extruder coming in. I did a serious water cooling system. I don't know if I showed that previously or not, but I've definitely modified it since I showed it if I did. So that's the water cooling system there on the wall. And I put a second pump because I had the small pump on the bottom, but I wasn't getting a whole lot of flow because I have this flow meter over here that shows you the temperature as well. If you can see that, it's a flow meter. It shows you the flow of the liquid as well as the temperature of it. So and then also I got new insulation. So I'm still going to use the bubble wrap insulation, the ductwork insulation, because of the air gap that provides. And then also I've got all high temperature wire. Let me just tip you down a little bit. All high temperature wire and all the gauges that I need. All different sets. This is high temperature wire sheathing because the tool head is not going to have any PCB on it. It's just going to be wired direct. so to the motor, and that's pretty much it. So, and to the sensor, which is a very cool sensor. It's going to be not a BL touch. It measures the distance between the bed and the sensor electronically with electromagnetic pulses. It's pretty cool. You can't have metal anywhere within a certain range of it. So I just have to build I'm going to make like a bracket to mount it. But it's going to be pretty cool. It can do like 150 measurements a minute. So essentially it'll take like 30 seconds to level the bed. And then this is the other high temp motor for the other extruder if I do decide to do both, because there's one high temp in there already. So this I may use on the, so I have from the fun mat, when I got the fun mat, and these are the other two heaters, which two of them are already in there. And then I screwed them into welding coupons, which are right here by the insulation. So this is how I mounted them so that it wouldn't, you know, not that the insulation would burn or anything, but just so it doesn't melt it. They're on welding coupons, aluminum welding coupons. So now it's going to be a lot more thoroughly insulated because I'm going to pull up that bubble wrap insulation I did, and I'm going to do this stuff underneath, which I have one more type of insulation coming. So let me just show you the different kinds that I got. So this is a really thin kind that's like a heat shield, but it's also going to provide a lot of insulating properties. So this is a I got two 2-foot by 4-foot sections, so 4-foot by 4-foot. But this is adhesive on the back, so it'll stick in nice and easy. I'm going to probably put this in the filament chamber and underneath above the electronics, because all of those electronics are being replaced. I'm even replacing the power supply. I have a 500 watt, 24 volt Meanwhile power supply coming in today or tomorrow. But the extruder and all the extruder parts came from AliExpress, so they're going to take a while to get here. And then there's this foam insulation, which is a little thicker and has reflective on the outside, so I'm going to use this in some parts where I have the space for it. And then I have one more type coming in that's like fiberglass instead of the foam, and it's about this thick. It's 8 millimeter thick. So I'm probably going to use the fiberglass, probably more than this. I may just save this because this is actually for sound deadening also, but it is tolerant up to some pretty high temperatures, just like the bubble wrap, which is going to be on top of it. So it's going to be very well insulated in the end, that's for sure. There's no two ways about that. It's going to be incredibly well insulated. So it's probably going to get a lot hotter in there than I anticipated. I'm only going for, at this point, 100 degrees Celsius in the chamber, and 200 on the bed, and 500 on the nozzle. So with the liquid cooling, I have liquid cooling blocks all over the place. Well, right now I had it set up, which, by the way, the main board blew before I even modified any electronics. That's why I was going to start this stuff when I had all the parts. I had the motors all laid out over here, and the board actually blew out while I was, printing with it the way it came. So that goes to show you how good the electronics are. I've only had it for a few weeks, but I knew I was going to have to do this. So I already have the main board and drivers. I'm just waiting for the CPU. I got a Raspberry Pi, not the regular one. I had gotten that other one that's already programmed. I'll use that for another purpose, but I got a E3 EZ Manta Big Tree Tech board. So, and all the newer mounted stepper drivers. So that's going to be the board. And then I got the Raspberry Pi 4 with 8 gigs of RAM. It was like a little under $100. That's going to go here. And then this and the power supply is really all I need. And then this 110-220 part is the only piece that's going to stay. So I may just take it off because I'm going to insulate here to keep the heat from getting to the electronics a little more, or at least behind each electronic component I'm going to insulate. So I may just take this off and put a piece there that covers over that. Same thing with, I'm going to change the power supply out anyway, so I'm going to do the same thing there. And then this board is coming out, obviously, and the subboard is not going to be needed. And there's not going to be a tool head board. Everything's going to go direct to the tool head. I already wired these all the way down. And even the extruder is wired all the way down here. It's plugged in somewhere. Where's the extruder? Oh, the extruder was going right to that. So, oh no, that was the X motor. The extruder, no, I didn't change the extruder yet. I didn't do the wiring for that yet. That's what that heavy insulated wire sheathing is going to be for. That's going to be for all the wires that go to the tool head. Because there's not going to be any PCB up there, so it's going to need some heavy wire protection. And I didn't want to do a wire chain because it restricts movement a little more. And that's some good heavy. It's very thick rubber. And then I also got some wire, some split sleeve. But this is, I mean, just check out how thick that stuff is. It's very well insulated and it's really thick rubber. This is tolerant to 200C. So this is definitely going to work for that. So the Bondtech extruder I was mentioning, this was made for the Fun Mat HT, which I probably should have tried this on the Fun Mat, but I didn't think of it. So that's a diamond tip nozzle, and then this was where that little peak tube went. And what I did is I just made it a little wider and tapped it M6. So that's a heat throat. So it's going to go directly into this, and there's no tubing in between it. I threaded it all the way up because this is a pretty long, I don't know if that's going to come out real easy to show you, but I have another one. Hold on, I'll show you the heat throat that's in there. I actually have a whole bunch more just in case I need them. So there's some that are very similar to the Fun Mat heat throats, which are like this. The only difference is that they get, you see how the top is not threaded, which is fine because it's got a like a counter bore or it's beveled to go inward, so the filament will go in either way. It's going to guide it right in, and plus I machined this up. All right, I threaded this up, so this is right about where it was coming out anyway, because it's only into here about that much, so it's right up to here, which is about where it starts coming out into the PTFE tube or the peak tube, whatever. So, and then there's ones that are threaded all the way up, which is, I believe, what I have in there now, but they're the same length, so it doesn't really make a very big difference. So yeah, it's right about the same place. So that's about how far the peak tube went up there. So it's the same difference, only it's all metal. And I'm going to put liquid cooling, which I have cooling blocks that I machined. I have cooling blocks that I bought. These are ones that I bought, and I just threaded in the metal fittings. So I have Capricorn high temperature tubing on the inside of the chamber, and then if you see in the back, I went with pneumatic 6mm hosing, and then I used all metal couplings, all metal reducers, all metal everything for fittings, and those reduce from the 6mm pneumatic to the Capricorn tubing before it goes in the chamber, which is in 4mm, and that goes to these all metal 4mm connectors there's no plastic on them whatsoever except for the O-ring that's holding it, which is also high temperature rated, and these are just receiving the Capricorn tubing, which is also, obviously, as you must know, it's high temperature rated. So I'm really building this to be a very high temperature machine. And I actually recently noticed, I started looking into the IDEX, and it's intriguing to me, and I actually bought one. I was going to get a Raise 3D, but the Raise 3D is they're pretty expensive. They're not crazy expensive, like $3,500 or because the carbon fiber one doesn't pique my interest because they want you to use specific materials. But even the regular E2, which is the other one that I was interested in, there's a lot of benefits to it, but it's a pretty closed system with Raise 3D. It's not. I would have to do and it has great electronics, but they're all closed loops. Like you can't modify much. So I would have to, I wouldn't use that for high temp. I'm making a high temp printer. I only need one that's going to print this high a temperature, but this is going to be a very fast printer when I'm done too, because of the additional power, the upgrade in motors, the potentially single extruder tool head. I may do a double and have this be the other part of it. If I do, I'm going to put some kind of cooling right behind this, So I'm not sure exactly how I'm going to situate it, but I actually considered making a bracket that went on the tool head that was water cooled inside the entire bracket. So when this was mounted, it would be mounted to a water cooled tool head carriage. I was going to machine it out of aluminum and make it in 2 pieces that are hollow with an O-ring gasket, and seal it together, and then have that be water cooled inside, so that this heat throat would be going through a water cooled plate, which I still may do that, or I may just use one of the really thin ones that I made. I have, hold on, let me see where they are. I made some really thin water cooled plates here in here. So I made this machining operation for a couple different diameters on my CNC machine. I guess I don't have any of the thin ones left. But even like a block like this it's a little too big because of the gear. But if I put it right here and go this part, no, I kind of want it, and it's too, the heat throat isn't long enough. I mean, I do have some meat I could take off of the top before I get into the open part in the middle. I could take like 1 millimeter off each side and make this thin enough to go right here in between, you know, right where the heat throat is. So this heat block would go right up to the bottom, and that might be too much cooling for the heat block, but it would be great for the extruder. So, or the other machining process I made is a perfect NEMA 17 fit with the screw holes and everything in the right place, and it has the center of it is like a radiator style, and it has fittings going in for the center part. So the hoses would be coming out of the front, but I could use elbows, and I could 1/4 inch thread it and use fittings that go from fittings like these. Hold on, put that back away. I could use fittings that would be like this. So I could even do 1/4 inch holes and then go like this. So they'd be like that. So they would be like this, coming out of the part that would bolt right onto the front of this into the NEMA 17, and then it would be like this. So I'm throwing that idea around, but the other extruder is a Manta, and it's a liquid cooled Manta. I have to replace the fittings on that anyways because they're plastic. I don't know why. I mean, maybe because it's liquid cooled, they don't think it'll melt. But with the chamber temperatures, I'm gonna be going for. I don't want to take any chances. So what I'm gonna do is I'm gonna use metal fittings like this that have, you know, they have all metal. There's nothing not metal on here. Even inside is all metal. There's nothing plastic on here. So, and the same thing with the end fittings that I've been using, like I said, except the O-ring, which is also high temperature tolerant, but it's all metal. There's no plastic push button. It's all metal fittings. So I have those in 6 and in 4 millimeter and the reducers, but I don't have enough in 6 millimeter, and also the 6 millimeter tubing is not, I don't know the temperature rating on it, but I know Capricorn is rated pretty high, so that's what I'm using. It does reduce the flow, but that's hence the second pump, and these fittings can hold a lot of pressure, and they have been, because that cooling system has been working great. And the temperature hasn't gone above 22 Celsius, even with the chamber at 70, 80 degrees Celsius that I had it up to previously. So, you know, and all my additional heat sources are on a separate power supply right here. I have a separate adjustable power supply. So there's nothing coming off of their electronics. I didn't do anything with their electronics before this board blew. And I'll show you where it blew. So right here at the bottom, let's see, I'll zoom in on it for you. Let me tip it down a little bit. It's right at the bottom of that board. Where was that? It was right here, right next to this. Okay, there it is. Sorry, when it gets zoomed in a little bit, it's kind of hard to see where I am. There we go, right next to that several wire white strip. Right there, right on those pins. And they have a jumper on them, which was previously installed when I got it. This jumper, that's exactly where it was. I hadn't touched anything on these electronics yet. These are the original drivers. I just started changing the motors and stuff, and these PCBs are in the middle of the motor. Hold on, let me back you back out. These PCBs are in the middle of the motor and the board. So there's one more of them that's abandoned right now. I'm going to remove it. But I mean, it does have high temperature wiring, but then it's soldered into this and split off into power and then a fan. I mean, power and then the motor, which I'm going to eliminate this and wire the fans right down, like this wire is going to the fan on that same motor with plenty of slack. And this is definitely high temperature wire. This is security wire that has a metal sheathing around the wire inside this insulation. So there's this insulation, then there's like an aluminum foil wrap, and then there's also the excuse me, brain fart. And then there's also the cotton. So there's like a cotton layer for insulation. Then there's fiberglass maybe, and then the aluminum sheathing, and then the actual insulation on the wires. You can tell is high temperature. It feels like these. It's this type of material on the high temperature motors. So that's for this is for the fan that is on the X motor. So that has a water cooling block, then it has a big heat sink that I added, and then it has on top of the heat sink, it has the brain fart. On top of that heat sink is the original fan, which I want to keep there because then it's going to be really well cooled, because that's the one motor that's in the chamber. And the other two motors, one of them, they're both in the filament bay, but I'm going to be insulating the filament bay around them, so they're going to be protected by the insulation. So also they're high temperature motors anyway, so, and they're going to be water cooled as well. I have two more blocks for them right in that same box I just showed you. And the blocks for them have an in and out on the top, so that they can go right on the side of them and have the hoses turn out and coming down, or straight out wherever it's easier to do it on those. But so this is a LRS 200 24 volt, so that has 200 watts. I ordered a 500 watt. So that is going to be supplying the 24 volt stuff, like the board and all the drivers and the stepper motors. This is a 220, which is going to stay because this is just a 220 control off of the board, which I'm going to be controlling with the new board. And this is going to stay because I need that for the bed heater and for the chamber heater. And then because of this, I may be able to use this for... it doesn't seem to have enough outputs, and I don't want to double them up. I have to check the specs on it. If this has enough amperage to put out, which I doubt it does, because the heaters that I got are 16 amp, 24 volt. So, some of them are, and then there's the ones that are 300 watt, 10 amp, or 300 watt. 24 volt. I can't think off the top of my head how many amps that equates to, but it's 300 watt. So I don't think I'll probably be using that. I may put it off of my new power supply, because that's 24 volt and that'll have a lot of power. Or I'll put a second power supply down here. I mean, this is a Meanwell that it came with. It looks like it's an old one, but I also do have another Meanwell power supply, not the one that's adjustable that I just showed you, but there's another 24 volt laying around here somewhere that's also a Meanwell. Oh, right here. So this one I may use for that. This is a 320. So it's still not as much as my other one, but you know what? The 320 may be good for the other components in the printer, like the motors supplying the board and doing everything that this one is currently doing, and more efficiently, and then have the 450 for the heaters. for the additional heaters. Or it depends. I'll figure it out. But I do have some help. I called around to a bunch of small shops that do like some assistance with these kind of builds, and not only with the builds, but with the Klipper programming. And that's how I found out that I don't need a PCB on the tool head. I don't need any subboard like this. I just need this main board and the CPU for it, which is coming in tomorrow. And the power control board will be here by then, but I'll be waiting on the extruder, which is why I'll probably do the BMG extruder in the meantime and just get it programmed and printing. And then when the other liquid cooled extruder comes in, I'll put that in and decide whether I'm going to keep them both and make a bigger mount, or if there's some part of the original mount that I can salvage, then I will. But either way, I'm going much further than I ever anticipated going with this printer. I'm basically rebuilding it from scratch. The only things that are going to be remaining are the frame and the linear rails and rods, rails, rods, and lead screws. So that, and the belts, I'm probably gonna, I haven't ordered any yet, but I'm probably gonna get the steel internal belts. Just because of the temperature and because of what I'm purposing this printer for. It's going to be a much higher speed, so I can do other materials in it, flexible, PPS, nylon, carbon fiber, like the PA6, PA12 carbon fiber and glass fiber. I can do a lot of, pretty much anything. I could do PLA on it if I want, but I don't think I'll be using it for that, because this printer, obviously, when I have the additional heat sources on, when I have the cooling on, it's going to be using a lot of energy. So there's no point in using a printer like that for PLA when I have two Bamboos and a QIDI, and then now a Snapmaker J1S coming in, which I'll do a review on that when it gets here. But that was only $1,200, and I went with that because it is Marlin firmware on it, which I would prefer it to be Klipper, obviously, but it's got a lot of good reviews and a good feedback that it works really well, and it's the fastest IDEX printer out there right now. So, and Raise 3D is also notorious for being slow. So I would want to modify some things on that, and it's going to be very hard to do because of the closed system that they have for their everything, for saving your prints and uploading them online, and even for filament, they want you to use their own filament, and I'm not into that. I don't. Bamboo at least doesn't expect you to use only Bamboo filament. And Bamboo, even though it's a closed system, I was able to modify the hot end. I was able to make some significant modifications, but it seems like Raise 3D is even a little more closed. And Creatbot had been helpful to a point with the electronics. They gave me a few model numbers for stepper motors, which I ended up getting different ones anyways. I just made sure that they could run on 2209 motors, which they can totally run on 2209s as far as the power they need. And he said 2209s as if these were 2209s in here. They're not. These are, I don't know why, because they don't have the power to need this, but these are 5160s. If you can see the small writing on here, let's see. Yeah, it's a 5160. So that's for the 3 XYZ, and then the 2 extruder motors. They do send an extra driver for 1 extruder, which is nice because not a lot of companies do, but I've never seen them send 1 for an extruder when they have 2 extruders and not for any of the 3 axis, but there must be a reason. So this is one of the extruder drivers. I'm not sure which models these are. They don't clearly state unless it's under the heatsink. But there's no reason for me to take it apart right now because I'm not using any of it. And I'm using much higher temperature, higher power extruder motors and all 3 axes. Except for the Z axis is an LDO high temperature standard. It's not the super speed. I only did those for the other 2 axes, and then I got the high temperature standard for the extruders as well, because there's no there's no need for the additional power or speed on an extruder or on a Z-axis. They're only going to move very slowly. So they do need the torque though, and the slower it moves, the more torque it's going to have, obviously. So anyways, I just wanted to summarize that. I will definitely make an update video once I'm in the process. Oh, and the shop is tinymachineshop3d.com or tinymachineshop.com. The guy that I spoke to, Kyle, is awesome. He was very helpful. He told me about that probe that would be good up to 120C. And it's incredibly fast. And he told me about a bunch of new hot ends that I didn't end up going with. I'm just going straight from the extruder to a heat block, but it's a liquid cooled extruder and a liquid cooled motor on the extruder. So I'm not going to need any more than that. But he gave me a lot of great ideas. So you can look forward to the next segment coming up where I'll be making some progress on actually making these improvements and getting this thing up and running. I'll talk to you guys soon. Later.